Good morning, everyone. I'll be speaking on the pathomechanisms of myopia. In that backdrop of myopia being projected as a global public health concern, we need to be knowing what is happening exactly inside the eye. So this is more of theory, kindly bear with me. So how does this refraction develop from neonatal age into adulthood? Need to know what is emmetropization. So this is an active regulatory process that starts in the postnatal period and gets completed by 6 years of age. So what is happening here? There is a precise matching of the axial length with the optical power of the eye. And any disruption in this active process leads to refractive errors. These are the developmental milestones. At birth, the range of refraction follows a Gaussian distribution, with the newborn having a moderate myopia in the range of +2 to +4 diopters. And in the first year, there is a reduction in the hyperopia due to the modulation of the axial growth. So in 3 months to 3 years, there is a progressive shift in the main refraction from +2 diopter to +0.75 diopters. And after the age of 6, divergent patterns of refractive development are noted. So axial length is the most influential factor which decides the myopia genesis. At birth, it is around 70 millimeters. By 1 year, due to the expansion of the vitreous chamber, it elongates to 20 millimeters. From 2 to 3 years, axial elongation slows by 0.4 millimeter per year till the preschool age. It gets stabilized by 6 years and increases only by 1 or 1.5 millimeters through the teen years. So two basic mechanisms operate in bringing about the development of a refractive error: form deprivation and optical defocus. So in form deprivation, the quality of the image formed on the retina is degraded. So the absence of a visual feedback results in choroidal thinning and axial elongation. The figures show the directional change in the axial length with regard to optical defocus. So in optical defocus, the focal point of the image is altered with respect to the retinal plane. So many theories have been proposed over the last 40 years. So much of research has happened in this area. And the key factor is thought to be genetic susceptibility to environmental factors like near work, night light exposure, diet, and stress. So how does this genetics work at a biochemical level? Creation of weak or degraded connective tissue is a key factor. So a known genetic factor is implicated in syndromic conditions like Marfan syndrome and CSNB. This recent genome-wide association study named CREAM found 24 loci associated with myopia, and all these are thought to increase the risk by up to 10 folds. So this has already been told. The impact of parental myopia: both parents are myopic means the risk in the child is increased by 2 to 3 times. And if only one parent is myopic, the risk is increased by 1.5 times. Environmental influences: it has been studied that the indoor light peaks at a longer wavelength. Sunlight peaks at a wavelength of 550 nanometers. So most of the beams which are received by the eye get focused behind the retinal plane, and that is a stimulus for myopia genesis. These are the different factors proposed: outdoor environment, chromatic composition, dopamine, vitamin D, and these lifestyle-related contributors: reading distance less than 30 centimeters, urbanization, educational level, intelligence, digital screen time. All these are thought to contribute. These are the different ocular expansion models: global, equatorial, axial, posterior pole, or it can be an asymmetrical expansion as well. Now, what is the role of retina in regulating the eye growth? It is thought that the retina has an inbuilt retinal image defocus detecting system which acts within the eye, and the retinal neurons also secrete a number of regulatory neurotransmitters which are thought to directly alter the ocular growth. Dopamine is thought to be a stop signal for myopia genesis. So a blur stimulus at the retinal level initiates a cascade of cellular and biochemical changes which are transmitted across the choroid and finally result in remodeling at the scleral level, responsible for increase in ocular axial length. It has been studied that equatorial and pre-equatorial regions, the retinal thickness is much thinner, but no change has been noted in the foveal region. And it is important to know that both central and the peripheral retina are important in driving the refractive status. This also has been told. The peripheral retina in myopes exhibit a relative peripheral hyperopia, and the peripheral, as is seen in the second image, the peripheral retinal image is focused behind relative to the central focus, and that serves as a driving force for increasing the axial length. What is the role of choroid? The choroid is high, with its vascularity, it is responsible for maintaining the ocular temperature, intraocular pressure, and it acts as a transfer channel for all the retinal signaling molecules to the sclera. Thinning of the choroid has been found to be the structural hallmark of human myopia. These are the changes which happen in the scleral level. There will be scleral tissue redistribution characterized by thinning of the collagen fiber bundles, reduced glycosaminoglycans and collagen contents. And it has also been studied that sustained accommodation during near work causes a thinning of the anterior sclera, mainly 3 millimeters posterior to the scleral spur. That is related to the peculiar pattern of arrangement of the longitudinal fibers of the ciliary body. These are the two theories suggested, mechanical tension theory and the accommodative lag theory. Mechanical force exerted by the ciliary body or the lens on the anterior part of the globe during accommodation is thought to accelerate the ocular growth. Similarly, the central hyperopic defocus is associated with a lag of accommodation during near work. That is also thought to contribute to ocular growth. And it is also studied that near task in down gaze changes ocular corneal astigmatism. It also induces some amount of higher order aberrations, because of which retinal image quality is affected. And it is understood that positive spherical aberrations are more protective than, they are protective. They actually inhibit the ocular growth. Near-induced transient myopia, thought to be due to a deficit in the sympathetic or parasympathetic input, is another entity. Convergence and extraocular muscle stress is also thought to contribute. And there is this on-off pathway that is also thought to have some role in myopia genesis. This is a concise model. Thank you.
Thank you.